Okay, so 0, 3. That would be a distance of, as r and theta, that would be a distance of 3 from the pole. So your r value would be 3. And so in what angle, direction, are we going 3 away from the pole? 3 pi over 2. Other possibility? So we could go to pi over 2 and then go negative 3. We could go negative pi over 2, takes us that same direction, and that'd be positive 3. So those would be other common possibilities. Questions on number 1? Questions on number 1? Okay. So I gave the 3 easiest possibilities here. What does r equals 2? What is that? What is r equals 2? Circle, so all points are 2 away from the pole, independent of angle, right? So it doesn't matter what the angle is, we're always 2 away from the pole, so that's just your circle, radius 2, centered at the origin. Okay, r equals theta. So r equals theta, what happens? So as whatever angle you're at, that's how far you are from the pole. So it starts at, when theta is 0, it starts at 0. By the time we get to pi over 2, what is r? Pi over 2. Pi over 2, so about 1.5. About 1.5. Pi over 2 is a little bit more than 1.5. So what? R is going to increase. So imagine theta, you're rotating through here, and r is constantly increasing. And then when we get to pi, what will r be? Pi. A little bit more than 3. So r is increasing, 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 increasing until it gets to pi. Then when we get to 3 pi over 2, what's r? About 4.5. Right? 3 pi over 2 is about 4.5. And then 6.28 is 2 pi. And so when we get to 2 pi, we're at r equals 2 pi. So this is just it's a spiral that just, the value of r is the same as the value of theta. So as theta increases, r increases. You move further away from the pole and you get an outward spiral. Okay, cosine theta. So there's 2 ways to do cosine theta. You could sketch this way, or you could do the algebra and change it into an equation of x and y. I'll do it the sketch way. So where's it going to start? At theta equals 0, it's going to start at 1. So you have the point 1, comma 0, where radius 1, r is 1, theta is 0. And then as theta goes from 0 to pi over 2, r goes from 1 to 0. So imagine, you imagine the angle sweeping here from the 3 o'clock position to the 12 o'clock position, and as it does that, r shrinks to 0. And that's what you get, something like that. And then as we go from pi over 2 to pi, r goes from what to what? 0 to negative 1. So we're really not drawing in the second quadrant. When we go from 0 to negative 1, we're drawing in the fourth quadrant. So going from 0 to positive 1 would look like this. So then going from 0 to negative 1 would have all the opposite r values. Like that. And then the second half of the cosine period there just repeats it again. You get from negative 1 to 0. which is going to repeat the top half of the circle, and then from 0 to 1, this repeats the bottom half. And if you change this into an equation of x and y, so r squared equals r cosine theta, and you work out all the math, you get the circle x minus 1/2 squared plus y squared equals 1/2 squared, which is the circle centered at 1/2, 0, radius 1/2. So either way, so you could do the math, you could do the algebra and get the equation of the circle and just sketch it based on the center and the radius, or you could use the cosine curve and sketch it from the cosine curve. Questions on the quiz? Questions on the quiz? Yeah. So x squared plus y squared. So we did one on last Friday. You can check it out in the video last Friday. So x squared plus y squared equals x. Then you can subtract x. You got to complete the square. When you complete the square, you'll end up adding a half to both sides. No, a fourth. You're going to add a fourth to both sides. That's what this is. And then you'll have the x minus 1/2 squared plus y squared equals. Yeah. But it's similar to the example we did Friday. Other questions? Okay, so let's look at in your homework. So you wanted 5 and 6. Let's look at 5. So 5, when we start at, first of all, so what's the equation of the curve? So we got a midline of what? Our midline is 2. There we go. So we got a midline of 2. All right, and then what is the period is? The period is pi. So we're going to have, what will give us a period of pi? If you had 2 theta, right? Because we know that b theta has to reach 2 pi, but the period is pi. Right? So when theta reaches pi, we want that argument to reach 2 pi. That means our coefficient needs to be 2. Or the value of b needs to be 2. Because the period's pi. So then what? And then we got plus 2. And then what is this? Well, it's definitely not sine because it doesn't start at the midline. Cosine starts at the max and goes down. So this is like the reflection of that, right? It's the reflection of that. So it's opposite cosine. So this curve is opposite cosine 2 theta plus 2 is r. Now to sketch it, it starts at theta equals 0. It starts at 1. And does what? As we go from 0 to pi over 2, it goes from 1 to 3. So it's going to be at pi over 2, it's going to be at 3. And we imagine as you sweep counterclockwise, the radius is going to increase from 1 to 3. Something like, I was doing great, and then I lost it. Something like that. So you imagine as theta increases from 0 to pi over 2, the radius increases from 1 to 3. And then back to pi, it decreases back to 1 again. So it's gonna make it back here when we get to pi. So it's decreasing, decreasing, decreasing like this. And then as you go from pi to 3 pi over 2, back to 3. Back to 3. R equals 3. Increasing, increasing like this. And then back from 3 to 1. So decreasing back to 1. So you get like a peanut. Yes, I am. Questions on that one? So that's when actually that one's kind of nice because you don't have to deal with negatives. So it's when you get into negative values of r that things get a little dicey, right? So those are harder examples. So this one's kind of actually a little bit easier because r never goes to 0 and goes into negative territory. Questions on that? Okay, let's look at this next one, and then we'll use the next one to transition into the new stuff. So we've got this one here. Again, it's also a negative cosine, right? So it's cosine but flipped on its midline. So that's the opposite of cosine. What's the period here? The period here is 2 pi, so we don't have to worry about a coefficient. It's going to be negative cosine theta. And then our midline is 2, and our amplitude is 2. So this one is r equals negative 2 cosine theta plus 2. All right, now we can use the sketch to sketch the polar graph. So as we go from 0 to pi over 2, the radius goes from 0 to 2. So you imagine it as you sweep counterclockwise, you imagine the radius increasing, 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 like this. So can you imagine the angle increasing from 0 to pi over 2? What would it look like for the radius to increase from 0 to 2? Something like that. Think of these, see these radial lines. On each radial line, you're further out on each radial line than the one before. On each one of these radial lines, you're further out than you were in the one before. So that produces this curve. And then from pi over 2 to pi, we go from 2 to 4. So again, along each radial line, we'll be further from the pole until we reach 4. So we're increasing, 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 like this, something like this. And then from pi to 2 pi, it's basically symmetric. Now we head back to 2 and then back to 0, kind of in a symmetric fashion. So we're gonna head back to 2 at 3 pi over 2. And then back from 2 to 0, from 3 pi over 2 to 2 pi. Okay, questions on that? Okay, so we'll use this example here to transition to new stuff. We're actually going to talk about some calculus now. I want to find the coordinates of the maximum of this curve. I want to find the coordinates of the maximum of this curve. So what kind of how would we approach this mathematically using calculus to find the maximum of the curve? So what kind of tool or approach or concept or idea would help us pinpoint the maximum of the curve? What's that? Okay, dy dr. dy dr. Other possibilities? So something to do with dy, right? Something to do with dy. What do we want about the change in y? At the highest point, what's true about the change in y? Yeah, so we want that change in y to be 0, but for what kind of change? What are you going to say? All right, yeah, so right, good. So by the highest point, we're talking about a y coordinate. We're talking about the greatest y coordinate. So where is r a maximum here? So that we know. Where is r maximum? So we can look at either graph and see that r is the maximum value of 4 at pi, 3 pi, right? So that's easy to see from the red sine curve over there. And also, where do we get furthest away from the pole? That's at 4 at pi. So yeah, so I'm talking about the highest point, which means maximize y, right? So I want to maximize y. So we want the change in y to be 0. We know the change in y to be 0. But for a change in y for what? A change in y, so dy dr for a change in r. Okay, another possibility, dy d theta. Maybe? Any other possibilities? But we're focused on the change in y. We want the change in y to be 0 to get the maximum. So we know for sure we want dy. So any other possibilities? Well, this is the most obvious one, right? dy dx, right? Now, which one of those is going to? So first of all right, is dy dr going to work? So we're saying for a change in r, does y stay the same? So that doesn't really make sense. Okay. What about dy d theta? So at that top point, if we think about for a change in theta at the highest point, does dy stay constant at the highest point? For a little change in theta, do we essentially get because we're gonna set dy d theta equal to what? 0, right? So does that make logical sense, or conceptually does that work? That for a change in theta, we want y not to change, and that's going to pinpoint our highest point. So imagine sweeping through here for what little change in theta does y not change? Yeah, that will work, right? That'll work. And of course dy dx will work. That's what you did in Calc 1. So both of these are possibilities. The question is, we have r equals -2 cosine theta plus 2. What's going to be the most convenient? Or what's going to give us the fastest track here to finding that highest point? dy d theta or dy dx? Yeah, so dy d theta is going to be a lot more convenient because we don't have y as a function of x. And if we tried to find y as a function of x for this curve, it's going to be nasty. Okay, it's going to be bad because we're not used to seeing those things in y and x, and so if we try to change this to y and x, it wouldn't be good. We'd have square root of x squared plus y squared. We'd have x's and y's and x squareds. And, yeah, so we're going to work on dy d theta. So in order to find dy d theta, we need y as a function of theta. So what is y in terms of theta? How do we find coordinates, the y coordinate of these points in terms of theta? R sine theta, right? That's what r sine theta. And what is our r? Well, for this curve, r is this, right? This is what our r is. Okay, so r is a function of theta. So we could write this, we could say r is a function of theta. And when we do dy d theta, what do we need to do dy d theta? If r is a function of theta and y is r times sine theta. So derivative of r times derivative of sine theta. Is that what dy d theta is? Derivative of the first times the derivative of the second? Is that right? No, what is it? Product rule, right? We got a product of two functions of theta, so we need the product rule. So it's going to be the first times the derivative of the second plus the derivative of the first times the second. So this is what dy d theta is. R times cosine theta plus dr d theta sine theta. Product rule, right? Product rule on what we know y is r sine theta. So we need the product rule since r is a function of theta. And it's for this cardioid, it's this thing we found here, -2 cosine theta plus 2. So we're going to put that in. We're going to get -2 cosine theta plus 2 times cosine theta plus, okay, what's dr d theta? What's dr d theta? Two sine theta times another sine theta. And if we want to find the highest point on this thing, we want dy d theta to be 0. Okay, so now we got our work cut out. We got some algebra and trig identities to do here to figure out what theta is that makes this thing true. So we'll distribute the cosine, and then we want to get everything in terms of cosine. So we got -2 cosine squared theta plus 2 cosine theta plus 2 sine squared theta. Now what we're going to have here is we're going to have a quadratic. We're going to have a quadratic in cosine, right? Or sine. We can do sine, but it'd be better to do cosine since we have the linear term 2 cosine theta. We want to change the sine squared to get cosine, so then we'll have a quadratic equation of cosine. So what does sine squared equal in terms of cosine? From the Pythagorean identity. One minus cosine squared. Okay, we're getting closer. So now we have all cosines and cosine squared, so we're going to have a quadratic equation of cosine. So how many cosine squareds do we have? Looks like -4 cosine squared. And then we have the +2 cosine. And then +2. And we want to make that equal to 0. So let's make our life a little bit easier here. Let's divide by -2. Let's get a positive coefficient here. We'll divide this whole thing by -2. So when we do that, we get +2 cosine squared minus cosine theta minus 1. And then we cross our fingers that this is rigged to factor, right? So we basically have 2x squared minus x minus 1. But instead of x, we have cosine theta. So does that factor nicely? We hope it does. So does it factor into what? So wrong place. What happened? Oh, let's see. Okay, does it factor? 2 cosine theta, cosine theta. So we need a -1 and we need a -1, multiply to -1 and add to negative cosine. So 2 cosine theta looks like +1, cosine theta -1, is that right? Okay, what are we doing? We're trying to find the highest point. We're doing that by setting dy d theta equal to 0. We're trying to figure out what theta will make dy d theta 0. So for a little change in theta, y doesn't change. And that isolates that highest point. Okay, So this says that cosine theta equals 1. Oh. Hmm. Let's try this. No, it's not really there anymore. Okay, but close enough. All right, and then this one says cosine theta equals negative a half. All right, so cosine theta equals, so which one of those two gives us an angle in the second quadrant, right? We're expecting second quadrant. So cosine theta equals 1 or cosine theta equals negative a half. All right, so this one right here gives a second quadrant. And what angle gives us a cosine of negative a half? Remember from your unit circle. So we want to go to negative a half. Cosine is, theta is 2 pi over 3. All right. How does cosine theta equals 1? How does that make sense in the situation, right? So cosine theta equals 1 means theta of what? 0 or 2 pi, right? 0, 2 pi, 4 pi. And so does it make sense that at 0 and 2 pi, we also have dy d theta equal to 0? Yeah, because at the pole there, it should be here, right? This should be the center. This should be the pole. I drew it, and then I can't get the file back on there. But at 0, at 2 pi, we have a horizontal tangent, right? So it makes sense that at 0, 2 pi, it's horizontal for just a moment. Just a moment at 0 and 2 pi. But then to get the maximum, oh, there's another theta too, right? So there's another theta that gives us negative 1/2. What's that? 2 pi over 3 and 4 pi over 3. Where's that? 4 pi over 3 is at the minimum. And that makes sense. It's in the third quadrant. So then how do we get the coordinates of that highest point? The y value of the highest point. So we could do that by, we need just the r. We've got theta. It's 2 pi over 3. And then we can get r from this. So negative 2 times, so r of 2 pi over 3 is negative 2 times the cosine of 2 pi over 3, which is radical 3 over 2 plus 2. And so that's negative radical 3 plus 2. So that's the r value. So that's our distance from the pole at that high point. We're negative 3 plus radical 2 away from the pole. And so then by multiplying r sine theta, and sine theta is 1/2. Or, let's see, what am I doing here? No, I got these backwards. This is negative a half. So cosine of 2 pi 3 is negative a half. You all were thinking that, right? You just didn't want to speak up. And then, so that's going to be distance of the pole of 3. So this should, and it's pretty good. This point is right on the circle of radius 3 because r is 3. That's what this says. Okay, and then so r is 3, and then to get the y coordinate, we're going to do 3 times sine of 2 pi over 3 is the radical 3 over 2. So the y value is 3r, 3, which is r, times sine of 2 pi over 3, which is radical 3 over 2, 3 radical 3 over 2. So we set dy d theta equals 0, and we got the theta we needed, which was 2 pi over 3. And then if we want the y value, we're going to use r sine theta. So the r value we get from the function when theta is 2 pi over 3, and then sine theta is just sine 2 pi over 3. So let's check that with the polar grapher here. So it's negative cosine theta plus 2, is that right? Okay, so the maximum point, we saw it was a radius of 3, right? R equals 3. There it is, right where it crosses the r equals 3 circle is where you have a maximum value of y. So it's 3 away. And it's at the angle 2 pi over 3. This radial line right here is 2 pi over 3. And it's on r equals 3. And so what is this y value again? Is that 2 radical 3 over 2? 3 radical, is that right? 3 radical, r sine theta. 3 radical 3 over 2. It's that highest point. Okay, questions on that example? Okay, what if we want to get the equation of the tangent line, say right here, where it crosses the y-axis? Another calculus question. We want the equation of the tangent line at the y-axis. So that would look something like this. What are we going to need to get that? What are we going to need to get the equation of the tangent line where this curve crosses the y-axis? Okay, so we're going to need the point. That's easy. What's the point? What did we say? So we're at pi over 2. What was our radius at pi over 2? 2. That gives us the point. What point does that give us? Okay, you should be thinking 0, 2. X is 0, y is 2. Okay, and the slope? Where's that slope going to come from? The slope is the more challenging part here. So that point is the xy point 0, 2. Because we got that from the sketch, and we sketched, right? And what would dr d theta be? So that's not really. We're going to write the equation of this line. We're really talking about x and y. So we want dy dx. And how are we going to get dy dx? We're going to get dy dx by dy d theta over dx d theta. And we already did dy d theta before. What was it? It was r cosine theta plus r prime sine theta. Is that what we had for our dy d theta? So then what is dx d theta? It's going to be negative r sine theta because it's r cosine theta. So the first times the derivative of the second, derivative of cosine is negative sine. Plus the derivative of the first times the second. So we're going to get dx d theta the same way we got dy d theta, where x is, x is r cosine theta. So our r is our function. And if we wanted to make this dy dx all a function of theta, then we'd find r prime of theta, we find the derivative, and we've got r, and we plug all that stuff in for the r's and the r theta, r primes, and we could get that whole fraction in terms of theta. And that would give us dy dx as a function of theta. So we could get any slope in Cartesian coordinates of the curve as a function of theta. Yeah, that'll be really, really messy. We're just interested in what dy dx is for this particular point. So let's make it easy on ourselves. What is r here? What is sine theta here? What is sine theta? And what is cosine theta? Okay, we need to put the 2 sine theta in. So we got r So I'm going to put the derivative in there, dr d theta. But from here, rather than get a function of theta, we can use all the information we know about our point in question to get dy dx. So r is 2. What is sine theta there? Should all know that. 1. What's cosine theta there? 0, right? Sine of pi over 2 is 1. Cosine of pi over 2 is 0 on the positive y-axis. So now we've got everything we need to substitute and get this dy dx. So it's going to be 2 times 0 plus 2 times 1 times 1 all over negative 2 times 1 plus 2 times 1 times 0. So because we're isolating a particular point, we can make it easy on ourselves and just figure out what is the r, sine theta, and cosine at that point, and then plug them all in. So we get 2 over negative 2, or negative 1. Does that jive with what the visual image? Does that, just as a mental check here, does that dy dx jive with what we're looking at in terms of our line? Yeah, negative. It looks like negative 1, right? For a change in x, you get the change in y, same change in y, but down. Okay, so what's the equation of our line? Y equals negative 1 times x minus 0 plus 2. Point slope form. Or negative x plus 2. Okay, and then if we want to do that line in polar coordinates, we could do r sine theta equals negative r cosine theta plus 2. Add r cosine theta to both sides. And we'd have r equals 2 over sine theta plus cosine theta. This is why lines are a lot more suited for rectangular coordinates, right? Lines are not suited well for polar coordinates, so you get kind of a weird equation that you saw in your web work. So 2 over sine theta plus cosine theta is the polar equation of that line. But lines are, right, they're diagonal. They're based on x and y coordinates a lot more in terms of like diagonals of rectangles, right? So y equals negative x plus 2 is the equation of that line. Okay, so you're going to do the remaining.